All right, so today what we're going to be talking about is literal equations. And so a literal equation is essentially just an equation that primarily consists of variables. Okay, and a good reason for working with these and practicing these is to just get work and get practice with manipulating equations and figuring out how to isolate certain variables within an equation. So we're going to go ahead and take a look at this first equation. Okay, we have ax plus by equals c. And now the prompt tells us to excuse me, it tells us to solve for the variable x, and by solve we mean isolate the variable x. So we want to know what x would be if we were able to isolate it. So if we notice, we have our x right here. Okay, and so what we want to do is we want to get that x by itself. And so what we're going to do is we're going to take the steps to get rid of the other things on the same side as the x. So we have this a right here, which we can think of as a coefficient, and we have this by right here, which would be helpful to think of as our constant. All right, so when we think about it this way, we can kind of look at this as a two-step equation. So my first step is going to be to get rid of my constant using inverse operations. So I want to get rid of this positive by right here, and the way I'm going to do that is I'm just going to come over here and I'm going to subtract by from my equation. Now we're doing it on this left side so that we can get rid of it. However, we also have to do it to the right side because anything you do to one side of your equation, you have to do to the other so that we can keep it balanced. So on the left side, after we zero out our by, we have ax left. And that's going to equal, well, we don't know the value for c, b, or y, so we can't necessarily subtract those and get a true value, so we're just going to keep it as c minus by. All right, so at this point now, we have ax equals c minus by, and let's think about what ax actually means. Well, ax actually means a times x, and so that's why I said think of this a as a coefficient, and so the way to get rid of our coefficient in front of x is to simply divide by our coefficient. Okay, so that means we're also going to divide this side by a. When we do that, we are left with x on the left side, and x equals, well, again, like our first step, we don't have a specific value for a just yet, so we're going to keep it as x equals c minus by over a, and that would be our answer right here. And that's all we're doing with these literal equations is we're just working towards getting a specific variable, whichever one it prompts you to get by itself. So in this prompt, it was to isolate the variable x. Okay, it just depends on what prompt you're on. So we wanted to get the x by itself. All right, so now we're going to start solving these just a little bit quicker now that we kind of understand the concept behind them. So we, again, are going to isolate the variable x, and we might recognize this equation as the equation for a slope-intercept linear equation. So we have y equals mx plus b, and again, we're going to isolate our variable x. And again, we can look at this as a two-step equation because right here we have our coefficient, our value in front of the variable we're trying to isolate, and then we have our constant right here, this positive b. Well, in a two-step equation, typically our first step is going to be to get rid of our constant. So I'm going to come under here and I'm going to subtract b. All right, and now to keep the equation equal, we're going to do it to this side too. All right, and now on the left side, y minus b, we can't get a specific value for it just yet, so we're going to keep it as y minus b, and that is going to equal mx, or m times x, if that's how it helps you think of that. All right, so now we just have one more step, and that step is going to be to divide by our coefficient, which is m. And by doing that, we will get our x by itself. So on the right side, we are left with x. It's going to equal y minus b over m. Because again, we do not know the values for our variables, so we're just going to keep them as variables. One more problem. And this one's going to be just a little bit more difficult than the other ones we did. So we have, we're called to isolate for the variable a, and we have g equals b minus c over a. And so what we're going to notice here is that the variable we're trying to isolate is on the bottom of the fraction. But that's okay. Let's go ahead and deal with that. Let's go ahead and multiply by a on both sides. So what that's going to do is get rid of this. Now, on the left side, a times g, we just get ag or ga, either one. Now, we have to remember that we're multiplying this a over here, not just with our fraction, but with our b. So we're going to get ab minus c. So we have ag equals ab minus c. Now, if you'll notice, we're trying to isolate the variable a. However, there's an a on both sides of the equation. So first thing we should do is let's get the a to one side of the equation. And we're going to take it to the left side right here because the right side has a constant. And it's just going to be easier if we can go ahead and move this over. So we're going to subtract ab on both sides. All right, so these zero out. And now we're going to get on the left side ag minus ab. And that's going to equal negative c. Now, what should we do here? Well, if we notice, both terms on the left side have a's. So what we're going to do is we're going to factor out an a. So we're going to have a times g minus b. And that is going to equal negative c. All right, so once we factor that out, we end up with a times g minus b equals negative c. And so lastly, and this is our last step, okay, to get rid of the g minus b, we're going to come under here and divide by g minus b. And we're going to do that on both sides, g minus b. And now this is going to cancel out. And on the left side, we are simply left with a, which is great because that's what we're trying to isolate. So a equals negative c over g minus b. And that right there is our answer.